Hi students. Okay, so I'm going to try to help you out with this assignment. I've had a number of students ask me for some additional help. So let's look at the simple example that I've posted in the discussion boards. So what I'm showing here in the first line is the DNA template strand, right? So DNA is double-stranded, and then it's unzipped, and then RNA polymerase goes along the DNA template strand, and we'll make a copy, a complementary copy of that DNA. So whatever, if there's for example, here is a T, and then an A, and then a C, so the complementary base pairing for that written in RNA would be T binds with A binds with U. Notice it's a U, not a T, because this is RNA. RNA uses U's instead of using T's. And then C binds with G, right? So as you keep doing through that, then you end up with the answer A, U, G, A, U, U, C, U, A, U, 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 A, G, right? So that's the complementary of all of this. But you had to also notice one other thing, that up in this strand, the codon, right? This triplet right here of C, 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 I said that you should assume that that is an intron. And what happens to introns in RNA processing? So this occurs in eukaryotes, right? That the introns get chopped out or taken out because they are the intragenic messages, right? They're between the actual message. And then you only keep the exons, and the exons are the expressed regions. And so you put all of the exons back together again. In fact, you can put them together again in different ways and in different combinations, and that's how you get alternative splicing, right? That's how we account for that one gene can make more than one protein. So anyway, that's how you now end up with 5 triplets instead of 1, 2, 3, 4, 5, 6 triplets. Notice there is the CCC, which would be down here, if it were not an intron, it would be GGG, and there is no GGG because it got taken out. Okay, it was spliced out or cut out. So then the next question says, what would be the second anticodon? So what are anticodons? You may recall that anticodons are on the tRNAs, or the transfer RNAs. So the first clue there is it's an RNA again. So that means whenever there would be a T, instead of a T, it's going to use a U, right? It uses uracil instead of thiamine. And then the tRNA is also, on one end, it has the anticodon, and on the other end, it connects to the amino acid. So the tRNA is actually the thing that does the translating here. So in order to figure out the second anticodon, I go to the second codon of the processed mRNA, which is AUU, and then I say, okay, what would bind to AUU? What would be the complementary codon to AUU? And so the A would bind with a U, because it's tRNA, it's written in RNA language, and the U and U would bind with an A and an A, so the answer is UAA. Okay, so for the third part, we need to look at what message is written using the single letter amino acid code. So we come back up to our processed mRNA, and it says AUG. Then we come down and look at our chart, and we find AUG. AUG right down here. So here it is, AUG. And that is methionine, and it's also the start codon, and the letter for that is M. So M is the letter, so I go ahead and write M. Then I go to the second one, AUU. AUU, here it is, AUU, that's isoleucine with the letter I, so I. And you keep doing that, and you end up with the word milk. Then you suppose that the 8th nucleotide, so come back up to the DNA, 1, 2, 3, 4, 5, 6, 7, 8, the one that's highlighted yellow, it mutates from an A to a C, so now it's going to be GCT instead of GAT, right? What would be the new message? Well, when you follow that through, you make the RNA of it and then look it up in the code, it ends up being an R. That's how this assignment is supposed to go. So you apply those same principles to the homework assignment, you should be able to get through that no problem. And if you have any problems, go ahead and email me or the TAs. Thanks.